My name is Thomas Rimza, and this is my third lab on the black hole. As for an introduction and a purpose, it was to find the mass of the black hole in a system that includes a star in orbit by analyzing momentum and force net components, then using this value of mass to find the initial velocity in which a spaceship is launched in the same direction as a planet is orbiting, in which the star would have the same motion, and so it would curve back around the black hole. The principles used were the momentum principle and Newton's second law, as well as the universal law of gravitation, and this is a preview of the results of the lab. As for the process in part one was to use and initialize a computer model with given position and velocity data by initializing the mass and time step, using momentum principle and second law to find F net, parallel and perpendicular forces, and find the total net force acting on the star to use it to find the mass in the law of gravitation. And for part two, finding the net force on the ship of the star and the planet by the black hole, and use the update formulas to predict the motion, then use guess and check to find the initial speed, x and y components of the ship so it would curve around the black hole. The main physics concepts were just to use the momentum principle and second law to calculate forces and momentum for the first and second part, and use the force found in the first part from the change in momentum to be able to calculate for the mass of the black hole, and followed by the same process, update the position and velocity of a ship that follows the same trajectory to get it to bend around the black hole. As for assumptions and reasonings, since we're in space, there's no traditional gravity assumed, so the only forces are the gravitation force, and from this we can assume that obtaining the position and velocity would be v final in terms of average, and using the momentum component, we are using calculus-based changes in velocity to find components of force while finding components of momentum. For the setup, our systems in part one is the black hole, in part two is the spaceship, and surroundings is the star in part one, and black hole and planet in part two. As for initialization in part one, setting the G constant, star mass, and delta T as shown, and then inputting the mass into part two from part one. As for the code in part one, we want to find the initial and final components of momentum, and then relate that to the change in momentum and change in velocity. From there we can find dp dt, which is the change in momentum with respect to time, and set that equal to F net. We want to find the components to find net parallel or force net parallel by finding the magnitude of or the change in magnitude of momentum with respect to time, and relate that to a p hat, and then finding the perpendicular component of dp dt by doing dp dt or net force minus dp dt parallel, and then this will finalize our force components. From here we can set the magnitude of F net to being mag F net, and finding the distance at which the force is applied. In the loop this will update, but in the end we found that the final mass of the black hole was equal to the second law with F net mag applied. So to find the average or final black hole mass, it was 1.78 times 10 to the 34th, and there was large variation due to the non-constant force within the time step. This is found using, or we also found the recorded force components. Inputting this mass into the second model, we had to set the mass and the given mass of time steps, constants, and the planet initial position and velocity. From here we can find the r vectors and forces with respect to black hole to ship and black hole to planet, and we can update the velocity and position from here. Then we find that it will curve around the black hole as seen in the model, with an initial speed of negative 1.9 times 10 to the 7 and 1.09 times 10 to the 7th in the y direction, being the planet in cyan and the model in magenta. Some sources of error was our time step might have been too big as the non-constant force is changing, and the guess and check method is not entirely accurate. What does this mean? Well, both components of force are respective of the change in momentum, but they show different things. Net force shows the overall acceleration of the object, but the components of momentum will show speeding up and changing direction. As for the what if we were to reduce the x component of the speed, it would be put into a orbit similar to the one shown, which here we find our black hole mass and initial velocity after mentioned before. The component forces are harder to find than finding them using the momentum principle, and the component's rate of change is described as the acceleration, but to put it back into orbit we would need to decrease the velocity.